Hey Chris, sorry it's taking me a little bit to get this video made for you. I'm just going to start off and do some adjustments to your file. So I'm just going to delete that. Actually, I'll go back. I'll just show you that you can actually type hide, and that will hide that object. All right, a couple things, just kind of like housekeeping wise. I figured out your dimensions were showing up kind of funky. You are in inches, but when you go to the gear here, we can access through this. Like I showed this earlier, through your units there. You can also go to dimensions tab, and we can do annotation styles. And right now, you had your annotation style set to millimeters small, so I'm just going to say new. Because what this is going to do is it's going to show you your measurements in millimeters, even though you're in inches each time. So somehow that got changed or something. So I'm going to do template inch decimal and say OK, and then OK that. And then now, since I'm in inches, whenever I do a dimension from one place to another, it will actually start to give me those dimensions in inches. Well, it should. For some reason, it's not. Let's see if I can fix that. Let's go back to annotation styles. It's because I need to click it. That's why. And so we can say OK. And like I said, now when I pull a dimension off of this, it should, yeah, it says 10.8. So now you won't have that issue. Again, it's easy to get confused if that's set. I don't know how that happened. Must have been something between the translation of your file or something. But so we're set with that. Now I'm going to make a new layer over here, just for me to make some sketches off of your file, because we really, for 2D milling operations like what I was telling you about with the stained glass kind of effect that you're getting here, or these window effects that you're getting here, you really don't need any 3D geometry if that's what we're doing. And so I'm just going to go ahead and make a sketch layer, so it'll make it easier later on when we're actually generating milling tool paths. We can select geometry pretty easily. I'm also going to show you a kind of interesting command that you might not know about. It's called curve boolean, and so you can click on that, and then you can basically select inside these regions, and it'll start to give you clean curves that are all joined. So that's pretty convenient to have that. So I'm going to hit enter, and now we should have some lines that are red. You'll see those there that designate kind of the windows of your piece. So that's kind of nice to have that feature. So it'll make it easier later on for these 2D milling operations that we're going to wind up doing. I may do some more of those. Let me just see if I can pull some more things off of there. I'm going to go ahead and highlight everything, and I'll do that command again, and let's see if I can grab. I want to see how you've got this kind of drawn. So it's weird, like it generates curves here but not there. So I may need to do some. I wanted to see what it gives me when I select on different parts of this. Yeah, let's see. Yeah, it's kind of weird how it's turned. So I do think you've probably got some issues with your water tightness of your model. There's probably some gaps and stuff that we're not really aware of. So that'd be something to maybe think about figuring out how to clean that up later on. Okay, well, let's go ahead and we'll get this going. So I'm going to turn off, just so you can kind of see. I'll turn off yours, and you'll see what I generated. So again, it gives us some closed region curves. So these will be good for us doing the initial kind of like roughing, or not roughing, but profiling of the model. So I'll turn those back on. Okay, so let's go ahead and set up RhinoCAM. So we're in inches, like I said earlier. You can see down here that we're in inches. I have a tool library loaded. I'm going to show you where that's at. So you can click on that blue screen, or that blue. Let me go back and click that again. So you can click right here, load tool library, and by default this will show up and you won't have anything showing. So you have to make sure it's in a data file. It should auto open to that location. but you just have to make sure that you either change it to all files or tool library files, and then you'll have a default set of English tools that you can load. That's what I typically do, and so when you load that, you'll wind up, you'll click on English. I'm going to say cancel because I already loaded them, but you'll wind up with a full library of tools. I don't get too hung up on putting in exact dimensions of tools unless I know that I'm worried about how deep I'm cutting. The main factor that's important is obviously the diameter of the bits. That needs to be right. That needs to be correct. But like length of cut only really matters if you're cutting thick stuff and you've checked against your end mill, and you can tell that you're going to wind up having a collision because it's got a larger shank than it does cutting diameter. So it's stuff like that, and so RhinoCAM will alert you of those things if you are plugging that information in. I again usually don't worry about it. I usually use a lot of straight shank cutters, so I'm not using reduced cutters that have a larger shank. So again, I usually don't worry about loading those exact specs in necessarily. It's not really gonna change anything unless you start changing with your speeds and feeds based on the tool chart that's built into RhinoCAM, even whether you put 2 flute or 4 flute. I mean, the program doesn't know what you're loading into the router, so I don't get too hung up on that. We can plug your dimensions in later. I'm going to go ahead and just generate everything without your tool, even the tools that you sent me today. Later on, you guys can plug those in, and again, I'll go over how to do that. Okay, so the first thing that we want to do is I'm going to show this so you can kind of see what's happening in all these views. I'll hit zoom extend so you can see. So we're going to first generate stock. I don't worry about this first column. There's a lot of stuff with like the setup of the part. There's already a setup by default. You can set your post processor. I have mine set to Tormach, but I can, again, when I post process, I can change that there, so I don't worry about that. And then the machine, I'm using a 3-axis. Again, this is kind of default settings. I'm not changing anything there. So I just start with stock, and I go box stock. You'll see that it auto-generates based on your model the bounding box of the object that you're going to be cutting. So this is showing this is almost 11 inches, right? And it's almost 1 inch. So if you did know you were using 1-inch foam, we would want to put that in at this location, right? It's right here. So if you were cutting out of 2-inch foam and reducing down, that would be important. I'm going to go ahead and set it to 2-inch just in case you're using 2-inch foam, and I can say okay. Now you'll see that the stock is setting up above the part. So the next thing that we do is we hit align. And aligning the stock, you'll see that when you first open this up, the default is to align the part to the stock at the top. So in this case, if we milled this, we'd have too thick of a bottom on the part. So you'd want to make sure and set this to bottom, and you'll see that it drops down. You could hit it to center if you wanted to center the part within the stock, and you were doing a flip or something on the mill to mill the other side that was also 3D. But in this case, we'd want to set bottom if our stock is in fact 2 inches thick. Okay, that's all I adjust there, and then I would say okay. If I go back and I make my stock 1 inch, right, and I hit OK, it really, it would matter a little bit because I think your part was saying is 0.99, but when I align this, you'll notice that if I change this, if the part is the exact size of the stock, it doesn't matter where you have that. You'll also notice that I don't typically, you may be saying, well, why didn't you put in the box stock, and why didn't you tell it that my sheet was, whatever it is I'm clamping to the table? I've just found that I know that I've got extra material out around it, but Rhino doesn't really need to know that. RhinoCAM doesn't need to know that. So I go ahead and just set it to the bounding box of the object, and then I correspond with the thickness. The thickness is the key element that's important. It's as long as your part is within that bounding box, then you're okay. So that's why I'm doing that. When I first started learning RhinoCAM, I thought it was really important to give it the exact dimensions of the stock in both X and Y, but really it's just the Z that matters, okay? There's a second tab in Align that's called Set World Coordinate System. This is where you're going to set your 0, 0, 0. Some ShopBot users zero the machine to the like southwest or southeast corner, and home it, and then that resets their 0 at that corner. I don't do that. I know the guys I work with, they all do that, but I basically tell RhinoCAM where I want 0, 0 to be. I put my stock down on the table, and then I just make sure that I reset my 0 to wherever I told RhinoCAM my 0, 0, 0 is at. So I usually do set to stock box, and I usually click center. I do center because then it lets me take my stock, if I've got a little bit of border around it, and I can X the stock, and then I can run the router over to the center of that X, drop it down, type in 0, 0 on my X and Y, and then I can go ahead and use the leveling plate to level my Z. So that's how I usually do it. You know, I notice when the guys at work start using the same corner to screw down their material, that corner of the machine just gets destroyed on the spoil board. So that's why I put mine wherever I want on the table, and then I just make sure and tell the ShopBot software where I've written it for RhinoCAM. Now, a couple things to mention on this. If I put highest Z, it's gonna you know, set it to, I'm gonna be setting my end mill to my stock. Some ShopBot users will set their 0 to their table instead. I think this just varies on what I'm cutting. Sometimes I will set it to the 0 or to the table, my 0 to the table. If I'm going to be milling something fully 3D and I'm losing my original stock as I mill it away, that's the only time I usually 0 to the table. And part of it, I think, is just the way my mind thinks. I like to be cutting in the negative so that my stock is 0. I'm cutting everything below that 0. Versus you know, if I level it or 0 to the table, everything I'm going to be cutting in the positive, and it just kind of, again, just for my mind, I like the simplicity of this, because I understand anything in the negative is cutting into the material. So I'll set the highest Z, and like I said, center, and I'll say, okay, now this will move my model over in Rhino's 0, 0 modeling location 0, 0, 0, and you can see I'm below 0 here in my other views. And we're ready to start setting up some milling operations. All right, I'm going to go ahead. I'm going to turn off some of these things because I want to show you. Maybe I'll put one thing in here, and I'm going to go ahead and let's see. We don't want that. Maybe we want part of your model that's the deepest. Okay, so that would be this section here. Okay, so I have just turned on, let me turn this off and see. Yeah, so that's setting the deepest. So I'm going to go ahead and in this view, I'm going to have to make sure this is active, the front view, because I want to bring those curves, those red curves that I created, down to the lower level. So I'm going to say transform, align, and I'm going to say at bottom, and I hit enter, and now what that's done is it's dropped all that geometry, the red geometry, down, so I can see now that's at the bottom of my stock. So I just did that just to simplify things for me. Later on when I start cutting some stuff, I'll know where all that geometry's at. Okay, alright, so let's get back here. And okay, so the first thing I'm going to do is I want to start removing material, and we're probably going to wind up removing some material just from these inner kind of forms, these windows. And so to do that, I'm going to do a 2-axis milling operation that's a profile. So we're going to profile around those windows. So this is where the geometry, making that geometry clean, and like I said earlier, like you don't even need 3D geometry to be cutting 2D tool paths, and technically it's called 2.5 axis because your X and Y is moving simultaneously, but your Z is the half axis, and it's only moving between levels, up and down. So it's not moving while you're cutting in the X and Y, so that's why it's considered 2.5 axis. So we're going to select the curve region. So again, if I would just basically turn all this off, I can easily select all these regions, and I hit enter, and then I can turn these regions back on, Alright, and then I've got all those red drive regions as the areas I want to mill out. I can select my tool, and in this case I'm just going to set this, you know, 1/4 inch bit can cut pretty quickly because it's a little bit more robust than some of those smaller bits. So I'm going to set this for a 2 flute, 1/4 inch. Feeds and speeds, I'm going to load from a file. And again, you may want to change these based on your machine. Let's say yes to that. And I can't remember what our spindle is. I want to say, I don't know if it's like, is it 12,000? Something like that maybe. And then I'm going to hit OK, and it should auto-generate some feeds and speeds, inches per minute, and that actually seems about right. I think the ShopBot can get up to almost 400 inches per minute. I think at least ours can. So you know, it's going to move fast between retraction and departure, but when it's cutting, it's going to be cutting about 240 inches per minute. So again, you know, you guys can look at your speeds and see how that matches up against your charts. And I'm cutting on it different routers. I've got my own router at home, and I've got a CNC mill. So I always kind of try to write that based on my table or on my machine, my specific machine, and the bits I'm using. Okay. All right. So clearance painting, you're not going to mess with. Cut parameters. I am going to choose here. I'm going to click this and say inside. So if you don't do this, it would cut on the outside of your window. It would, you know, destroy your design since you've got these thin areas between. So we want to say inside on that, so it's going to cut inside the curve. And then we're going to say sorting, we don't need to worry about. We could start to save a lot of time here if we're messing with this and we wind up, you know, if it's cutting over here and then it's going over here and cutting over here and then it's cutting here, we can look at the simulation and see if it does that. But if it's cutting in a random way, you can say minimum distance, and it will cut it in a more whatever's closest to the last thing it cut. Cornering parameters, I'm not going to mess with. Advanced cut parameters, this is where we're going to put in some bridges. So I'm going to put in some triangular bridges, and we'll say that we'll put in maybe 8 of those per section per window. And then we'll say entry exit. You want to make sure you say a long path. If you don't do that, what it does, it kind of comes in from the interior region, and the reason it does this is it gives you a cleaner edge if you'll do an entry that's on an arc. So it'll come from the inside and into the line that it wants to cut, and kind of go around it. I always kind of cringe because I always forget to click this apply entry and exit at each level, and so you know, if you don't do that, it engages at the same spot, but then when it exits somewhere else, and it exits at full depth. Now if you're cutting a hard material, that can get a little sketchy and usually wind up breaking a bit. So I'm pretty much in the habit of just doing a long path, and I say a 45-degree ramp angle, and then I say none on the exit, and apply entry and exit at each level, and that way it'll ramp in kind of slowly instead of just plunging, and we'll leave it there. You might wind up with a slight entry and exit, and what causes that? It's usually only in hard materials. You get a little deflection of the bit, and so you'll wind up with a slight ridge in one spot where it's entering and exiting a cut path. But again, on the foam, it shouldn't show up there because there's hardly any load on it. All right, so total depth of cut was going to be 1 inch, and then I usually don't mess with the rough and finish settings, but I do just go ahead and give it an increment that I'm comfortable with. So let's say you're cutting this foam, you probably could cut 0.25 1/4 inch depth of cut, and what it'll do is it'll calculate across that 1 inch 1/4 inch at a time, and it'll make that number of passes to get through that material. And that's all we need to do. We can just hit generate, and it will generate some tool paths. So we can click on this tool path. Now you'll see that this tool path is way below where it should be, and the reason that is, I just wanted to show you this, and this was confusing when I first started using RhinoCAM. You have to tell it where the geometry is in this cut levels, and so in our case those lines were all at the bottom. We made sure that's why I aligned them at the bottom, so I could come back and click this, and then I can say generate again, and now you'll see they're generating the tool paths up top. So see how that looks? So again, if we simulate this, we can watch, and you'll see, okay, so it says holder shank collision error. Do you want to continue? So it's even giving us a warning that says saying, hey, you're gonna the bit you're using is not long enough. So we'll go ahead and say no to that. And then let's go back, and that's what I love about RhinoCAM is we can go back and adjust this, you know, at any point that we want. So, you know, if we're cutting, let's just see, we can double click on this, and this is where you could edit your tool. So if you wanted to make a new tool, I'm just going to go ahead and say, you know, we'll say rename this here, new 0.250 2 flute, and I can say, you know, shank diameter, and in this case it's saying 0.25. Tool length, you can see what that's showing you, full tool length. So we shouldn't be hitting there. Tool diameter, flute length, right? So flute length isn't long enough. So, you know, we might want to say that that's, you know, again, based on whatever our cutter is. So I'm just going to tell it it's 1, you know, and I could give it a shoulder length of 2, you know, and we've got tool length of 2.5, and again, this would be different, right? So this is no longer accurate, but then we'll just say save as new tool. You'll see that this kind of edits how this looks over here. So flute length we might want to make maybe 1.5 instead or something, and then we should be able to have that, and we'll save as a new tool, and it's telling us that number is repeated within our tool library, but we'll say yes to that, and because we're not using a automatic tool changer. And then we'll exit, and then you'll notice that when we come down here to the bottom of our tool list, there's a new tool listed. So that's how you could create a new tool. So I'm just going to go back and select that, and then I can hit generate. Whoops, let's try it again. Oh, what do we do here? Okay, so now we have that. Okay, so now let's see if that winds up looking right once we simulate this. There we go. So now it's telling us, you know, it's not giving us any issue there. And again, we can see our tool paths. I'm going to turn off the tool paths for a second so you can see what it's doing. So that's going to save you a ton of time. You can see our bridges that it's putting in. It'll save you a ton of time on your file, and the fact that it's not going to have to just, like, you know, 3D mill all of that to get through that. So that's one way we can save a little bit of time on your particular file. All right. Okay, so the next thing we need to do is we need to set up probably a different milling operation. I'm going to show you what I like about Rhino. I'm going to skip ahead to the end actually of what we would be cutting. So if I take and I copy an operation and then I paste that operation, this is kind of cool. You can use all the same settings, and because we know that we're going to be cutting out the outside of this, I'm going to hit remove all, and then I'll select curve regions. I'll click this, which is your original outline. I'll hit enter. Now the only thing, because this is a full depth cut that we need to cut as well, the only thing that we would need to change would be in our cut parameters. And because we want to cut on the outside of the line, we click that and we hit generate. And now it will generate a tool path for the outside of cutting this from the stock that you have. So I always like to do that as a nice way to kind of come around and clean up that object, regardless of whether I'm 3D milling or not. It's just a nice thing. So we're going to fill in all our operations in between here. Okay. All right. So it's like this will be our first, and then we can, if we wanted to, we could stop the machine, remove those windows, by X-Acto knifing the bridges, pop those out, and then we can continue milling. All right. Okay, so a couple things we could do now. If we just want to do like a parallel finish, I'm going to show you what that looks like. And I think this is probably what you've been doing, is you've been running a parallel finish across the entire object. I'll just run it and we'll see. I want to see how the geometry looks running it that way. So we'll do a parallel finish, and with parallel finish, it just auto detects the 3D model, and so I don't have to worry about it. Now, I would usually, when I'm doing a parallel finish, I would use a ball end mill of some sort, and so I'm just going to again choose a 1/4 inch 2 flute for the size of this object. I'm going to say feeds and speeds. We'll do load from file. All right, and we'll choose the same settings. And then we will, clearance pane we're not going to mess with yet. Sorting, I don't need to worry about. Advanced cut parameters, I don't need to worry about. Entry exit, I don't need to worry about on a on this 3D file or 3D profile. I may set a lowest Z just to keep it from hitting into your table, because right now we're at -1, but sometimes the tip will sometimes kind of touch down. So we can always come in and specify a lowest Z just by clicking on the object, which this should correspond to. That is 0.1. And then cut parameters, I'm going to leave as it is stock, but I'm going to show you some different things with that later. Okay, so we've created a parallel finish process across this. So now that we have that, let's go simulate that and look at it. Okay. I'm going to maximize our perspective window, and I should be able to play this. I'm going to turn off our. So it's colliding there, it looks like. And we'll say no. So I forgot to choose the correct bit. So let's stop that. Let's go back, double click our parallel finish, and then tool. We can choose. Again, we may have to modify our tool so it's a little bit longer. So let's just do a new ball. There's that. We can bring this into position, and then flute length. We maybe want to say that that's 1.5, and again, you'd want to take this off your tool, and we're going to say new. And shank diameter, tool length. We've got is 2.5. Shoulder length. Let's make that 1.5. Tool diameter, save as new tool. We'll say yes, and then we will exit. And now if I regenerate that with our new ball, let's see if that does that properly. And we can always drop these down and we can see there's our new 2 flute ball. And let's go ahead and simulate that now. Now you see we're getting a lot of kind of ridges in our model, and I'm going to show you. There's 2 things that can that we can adjust, and I want to kind of demo this for you so you can understand what I'm talking about. Let's just go ahead and let this finish. So, so there's 2 things we could do. One, we could change the step over, which we talked about. I think in reference to mowing the lawn, right? And then the other thing that we could do is we could take the model that the simulation that Rhino uses. There's 2 options. There's voxel and polygon, and I'm going to show you where that's located, because the simulation is always a little deceiving. At least I found in RhinoCAM that your surface will actually wind up being a little smoother than what it shows. Okay, so in this case, we'll go back. We can go to the gear here, and there's a place simulation, and you can change from polygon to voxel, and then we rerun the simulation. All right, and so you may see that the when you rerun this, you'll see how choppy that looks. So if you're in voxel mode, it's faster, right? It processes faster in the simulation, but the ridges will be more pronounced. So just make sure, if you're like basing your how the file's going to look off the simulation, that you remember that there's maybe a set as voxel versus polygon. So again, just check your preferences there in your simulation to make sure polygon. And then the other thing you can bump up your simulation accuracy. Right now it's set to standard, and then you can bump it up to fine. Now that will make it processed longer, but that would be the other thing, that if you wanted to get a more accurate representation of how this was going to look. Oh yeah, I gotta go back and, sorry, let me stop that. It says I didn't do the first path, so it doesn't know what to do there, so there we go. We'll watch all that, and you can see that's much smoother already in terms of like even just the simulation. Now we still have our ridges, so let's just go ahead and stop that instead of rerunning the whole thing. Whoops, stop. Alright, so let's double click on this. And so what I'll do a lot of times, instead of, you might think, oh, well, we need to run a smaller bit over over that object in order to get a better finish. Well, it's kind of surprising, but because you're using a ball end mill, the tip of that ball end mill is all this really coming into contact if you set a very fine percentage step over. So I can set a 5% step over with a 1/4 inch bit and still achieve a pretty amazing finish, or at least I should be able to. So we'll let this finish up, and you'll see it will be more lines if we turn on the and you can see there's way more resolution essentially in those lines. So let's play that now so you can see what that looks like, and we'll turn off our tool path. So you can see you're getting a much finer finish because it's barely stepping over, and you're just using the tip of that larger bit, which again was probably contrary to what you might think. You might think, oh, we need to use a teeny tiny bit, and that's not necessarily the case. Especially as you're starting to mill thicker stuff, you're going to be limited. Little bits only, the small end mills only, they only come in certain length of cut. Because of how fragile they are. So you can actually get away with using a quite large bit, large end mill, if you're using a ball end mill, and you'll get a pretty fine finish. As the main thing is, as long as the bit can get down into your voids. That's the kicker. That's where you move to a smaller diameter end mill, is if you can't get into the regions, and RhinoCAM will just avoid them if you're writing it for a large bit. But this would start to give you probably a pretty nice finish, and I'm just going to kind of watch and see how this looks. And again, we can speed this up too, speed up our process, but it's taking a lot longer to generate this simulation because of the detail accuracy that we cranked up. So you probably don't want to do this until you're ready to actually cut it. So we'll just let this run, take a look at it. Looks like we're getting a pretty decent fillet there too, and that's the type of stuff that I've gotten to where I'm starting to not model as much, because if I know how the end mill is going to hit a region, it's not worth the time of sitting there messing with fillets in Rhino if you understand what the CAM software does. And that's what I was telling you, like even being particular about your Rhino modeling here in the beginning, it's like if you actually understand the CAM and what it's doing, you can start to create textures by changing your step over, by changing the direction that you're running. I think that's where the real potential is for artists to experiment, is in that kind of realm, and not spending as much time, detailing out the model, especially like I said, because you don't need a ton of information to be able to mill out things. And even I was looking at your file, and so like we could have milled out, we could face that section that is where the windows are. We could do a 2D operation, a 2.5 axis operation called facing, where we actually face down to the level of where that model is located. So we could divide this model up into kind of different parts, face the one section, then cut the windows out, and then come back and just do the 3D area only. Okay, and I'm going to show you here in just a second when we get done. Actually, I'll stop this because this is kind of, you get the idea. Alright, so if we go back to this, and if we wanted to limit the parallel finish, I'm just going to show you how you can start to isolate. So like I said, by default it will try to do the whole form, but if you select a region, if you said I would like to isolate that 3D milling between here, and it would have to be a closed region, so I got to make sure this is where I think if your model's not if it's not like watertight, you can see like right in here there's a little segment I got to make sure I get, so you got to be really particular about this. And this is also, I didn't realize this existed in RhinoCAM, but you can hit enter now. So if you said, hey, I just want to, you know, parallel finish that one section. Okay, so it says there's an open curve there. It would let you, if we made sure that we, you know, we didn't have a gap in there, and apparently we do. Let me see if I can find where that's at. I'm guessing it's over in here. Maybe not. Might be there. I'm not sure. Let me try a different section. So let's remove that. I just wanted to show you how it can isolate an area. Let's just try, like, for example, maybe here. See if we can get this to work. Yeah, this is a little funky in here, I can tell. So there's a curve, and then there's the poly surface. So you can tell what your poly surface, there's a curve, but the poly surface isn't tight to that. But let's do that poly surface edge, that poly surface edge. And you can see there's an overlap there. Yeah, it's not going to like that. Let's control click and deselect that. My mouse is poly surface edge. Hopefully those join up. If they don't, you know, it's not going to let us do it. But and again, these have to kind of meet up end to end. Yeah, and that's where I think you're running into trouble with your model, maybe. I'm really just wanting to get this. Yeah, something's funky there. There's a strange thing happening there. Yeah, it's not letting us. It's probably not going to let us do this. I was wanting to show you. Let me hit escape here. Let's try a different section. I wanted to show you that if you had a. Let's try this region and see what this does, just from your curves. Let's generate that, see if it'll let us. Yeah, open curve there, so something's not. Oh yeah, well that's obviously, yeah, open curve because it's. Whoops. Can see where this line continues. So, you know, it looks like you're getting some funkiness with your original curve. I think it's how you're drawing your curves maybe in the beginning. But let's remove all. See if I can find another clean section here to grab a hold of. Just was trying to show you how you can isolate a section and just do a section only. Let's see what's clean here. See if we get a error here. I'm gonna do a section like this and see if we can make this work. Okay, so let's see if this is all connected. Let's generate that. Nope, doesn't like that either. Okay, well, I think this is where your problem is at. I think that your object is not quite watertight. I'll show you this too. You can select your object or any surface. So you can select a surface like this and you can say check. So that's a valid poly surface. That section is, okay? We can click another section and we could say check again. That's valid, right? But like some of this needs to probably be union together to make a complete kind of form, because like these are touching, you know. So okay, let's check this. Okay, that says it's valid, but I wonder if it's actually watertight or not. Yeah, because I mean, even that, like, normally you would have this and this joined. What do you have there? You have two. You have two of the same thing. Looks like you do. Looks like you've got some duplicate. Let me hide this. Okay. So you got duplicate surface there for some reason. Not sure why. Let's hide that. Let's show. So show will bring it back. So you do have duplicate. Why is that? I'm going to delete one of those and see what that does. See, normally this would be Boolean unioned to this. Let's see what happens when we union that. Solid union. It doesn't have to be to mill it, but like Boolean failed, so the union failed. So that again, that tells me there's something up with the file or with your drawing. Let's try unioning this. So we want to union this to this. Union failed. Didn't like that either. Okay, so I wonder if you're not setting. Okay, so you got that. You got that. See, that unioned. Okay, so that was good. So when we click on that now, and that's going to help, you know, to let you know if there's some issue. Yeah, it doesn't like that. Which is funny that it liked the other one. So that makes me think that if we just deleted this one and then we mirror this one, let's see if it lets us do that then. So transform, mirror. Let's turn on midpoint. Hold shift. Okay, let's try a union on that. Solid union. Sorry, we're running into some modeling stuff here that, you know. Yeah, see that union fine. So there was something bad with that surface, or with that poly surface. And then we can union that. So, you know, now those are joined. Typically we would union this and this. Yeah, see that? It was fine there. And this and this. Okay, so that's one surface now. Just wanted to check that. Going to look at this. If an object is floating above another object, it sometimes will not, like if it's not actually like intersecting. Yeah, you can see you got some funky overlap there. So your lines aren't, you can see right there. I think, you know, I'm not sure if that happened when somebody fixed it, or meshes are kind of messy, so I don't usually like working with meshes, and it looked like earlier it said it meshed that, so because you must have had a mesh there. Let's try unioning a few of these things and see if it'll let us do it. Yeah, it failed. See that? Well, regardless, let me at least show you what I was trying to show you. We know that you can just, you know, parallel finish the whole thing, and maybe that'll give you the surface you want. But I do think if you start to model a little bit more accurately, I think that you'll have better results. So let's remove this, and like let's, for example, just do a section of maybe this. We know that we know this is clean now, or it should be. Blow this up big so we can see it. Yeah, so that'll give us, you know, that's going to give us a toolpath. See how, and this is what I was trying to show you, is like you could just do sections instead of trying to mill the entire thing at once. You can start to use different bits for different parts, so that way you can mill things fast in the areas that you want to remove a lot of material. So again, if we simulate that, you know, you start to see how you can just control that section of it instead of just kind of doing a full-on, you know, sweep over the entire object. Alright, so okay, so let's go back then to our program. I guess the question becomes, you know, do you want to remodel and clean that up so that you are just milling, you know, regions and being able to control that, and then you could just do like a facing operation on all of this, because this is just flat. Like, there's no reason this has to be 3D milled. And again, you could mill just you would just isolate all the geometry, so you're only facing this right here. You know, you're not facing in here, because like when you do the parallel finish, you're dropping, or at least you're lifting up and going over those. I'm going to remove all, and I'm just going to select. I'm not going to select anything. I'm going to hit generate. We'll let it generate it, and then I think that's why you were getting artifacting though in the previous file. I'm going to hide that again. I think that's why you were getting that. Yeah, and actually I turned that on so it generated a path there, so let's regenerate that now that that's hidden. I think that's why you're getting that artifacting, because there's still some things that aren't quite unioned, or things aren't setting on top, or they're overlapping, and so you can see here now there's a couple things that we can change. If you're okay with the way this looks, I'd say just run it, you know, the way it is. If you are like, no, I wanna go back and fix those things, then you'll probably have to remodel. But I do want to show a few other things. So right now you'll see in the red, that's where the bit is lifting in and out, okay, of the cut. And so we can set this to our clearance plane to skim, and you won't lose the time of it lifting up and out. And we can hit generate, and you'll see that this lowers down. We'll eliminate all these, so it just skims the surface. So this will save you a lot of time. It'll just be running up and over the surface of where those cuts are. But you'll find, so you know, your model was not looking good because it wasn't getting down in. It was kind of creating a fillet and curving there. Because we've done this profiling finish, and again, we could move this at any point we want in the process. We could move it down there if you wanted to. So if you wanted to start off and do a ball end mill first and then come back and clean this up, you'll be able to tell what it looks like here. So if we played that, again, I'm not going to do it at the settings that we had, because that would just take too long. But like if we move this to minimum, we say okay, and then we simulate this. Whoops. And I'm going to speed this up. Did I not change the right thing? I think I changed the wrong thing. Let me go back. Simulation. Standard accuracy, yeah, I didn't change that. Okay. Okay, there we go. Now, if we simulate this, we'll hit play. We can go through this. Sorry for the long video too. I know this is kind of long, but I hope this helps you guys out. Let's see how it looks down in there. That may be okay. I mean, you may be able to get away with. You know, so when you get roughness like in this kind of chatter in the corner here, we could run this parallel finish. Right now we're running this way, you know, but we could copy that same parallel finish and run it the other direction, and we might be able to clean some of that up. It just depends, and I'll show you how to do that as well when this gets done. I want to see what it looks like though with those windows cut out. And you can see it's just avoiding those sections, you know, it's not dipping down in there because the bit is so large. And so this is kind of nice because you don't, you know, the end mill is so large. Yeah, it did dip a little bit right there, you can see. So plunges there, but everywhere else it's like, oh, it's too tight of a radius to get in there. But this will allow you to cut a lot faster because you're cutting with a bigger end mill. So again, just, you know, RhinoCAM will avoid any regions where it can't get that bit in there. So you kind of use that to your advantage. You're taking advantage of that. Okay, almost there. And you know, I know it takes a long time because we've got set that 5% step over, but it's going to leave you with a nice finish, hopefully. Alright, now it should switch over to our profile. It's going to pocket out those regions. Not pocket, but profile. Okay, so you can start to see then, and then we'll do this outside. So we can start to see that we get a much cleaner finish. You know, now, is it getting as deep as it should? That's where you probably want to switch out, you know. So this bit would, the 2.5 axis profile would probably be a smaller diameter if you want to make sure you're getting way up into those corners. But I don't know that you have to use a teeny tiny bit. Again, just depends. But this will give you, it'll still give you a clean cut. It just may not match your geometry exactly. So that's where change to your smaller bit if you want each one of these radii to be, specifically exactly what your file was. And that's just a matter of you then double clicking on this and going back and changing your tool bit, seeing what it looks like. And so sometimes I'll copy and I'll paste in a new one, a new operation, that's a new profile, and then I can change that out to a different tool. So we could make that a, whatever I don't know if you were using an 1/8 inch, I can't remember what you were using, but you could do an 1/8 inch, let's see, that's 750, probably won't be long enough again for that 1 inch. It'll tell us there's a problem probably, but let's generate it and see. And then we can simulate that. We'll see if it'll let us do it. Yeah, we'll say no. We'd have to change the length of that bit, so same thing. Go back, double click that, and we'll say new, and we'll say that's 1.5 and 1.5, and tool length we'll leave it 2.3. Save as new tool holder, or sorry, save as new tool. Yes, save that as a tool, and then exit, and then we should be able to go down, select that, and generate, and then we should be able to simulate that. And you'll start to see, up in these regions, we'll wait for it to get, see how it cleaned that up right there when I zoomed in on it. So that bit's going to get you that tighter radius that you want. So again, sometimes I'll even run it twice. I'll go ahead and run with a 1/4 inch just to kind of rough things out, and then I'll come back and clean up with a smaller one. So I just wanted to show you that's a real easy way to kind of make adjustments. Now, the other thing I want to show you is we can take this parallel finishing operation and we can copy it and we can paste it, and then in parallel finishing we can take the entire file and under cut parameters we can change the angle of cuts to 90 degrees, and we can hit generate, and then your tool path will be going this way. I'll turn on the tool path so you can see that. Alright, so now it's going to come in and clean that up. So sometimes I'll run two, while I load that bit, I'll run two different parallel finishes across it, two different directions. Some I'll even do a 45, so I'll do a third one, and you can really get a super clean finish. But I'd recommend just running that first one and seeing what it looks like, okay? And then I guess, I don't know if you know how to post-process or not, but if you're using the same bit, you can go ahead and just kind of batch post-process these. So I'm going to hold down on shift and I can post-process these together. So I just go to post, and then this is where you would change your post-processor, and in our case you guys are using a ShopBot, so we go to ShopBot, and the Rev1 is the one that you'd need for the startup sequence I was telling you about. And so we'll just go ahead and say, panel. I usually do if it's the first bit, I'll do O1 panel, or let's do Chris because I had another panel earlier I'd done. So Chris panel, and then this you'll hit post, and you'll see mine's going to do as an NC file. You'll have to change in ShopBot software. You'll just have to make sure that when you go to load your file, it'll be looking for a SBP, I think it is, and you can change that to .nc, so it'll recognize .nc when you go to do it, and then you'll post it. You'll get your G code for that, so it should pop up here in a second. It's a lot of G code for that because of that tight step over, so it takes a second for it to generate usually, especially since I'm putting the two together. So there'll be a lot of lines of code, but there's that C6. The C6 is the command for starting the spindle. So if you have that sequence, that's what that Rev1 puts in there. All right, and then we use the same. Well, I guess we didn't use the same bit for this one here, but if we were going to post-process both the 1/4 inch and the 1/4 inch, obviously I'd wait on the outside to release it from the outside. So I wouldn't generate those together, so you could just do, post that file by itself, and then this would be like, crisp panel, and we'll do two. Sometimes I'll put the diameter of the bit in there too, so I'll be like, 0.25 flat, just for a naming convention, and then we can say, post. And so then there's a G code for that, and then we do the same thing. We post this one. So you're gonna have a tool change in between, each one of these. So this would be 03, and then all you'll have to do is 0 your bit each time you're on the Z. You'll just 0 the Z only to be able to post process. This one will be a 0.125 flat. And there's that G code, and those are profile stuff. Post process is really fast, so it's really simple. And then we have 04, and this would be 04 and 0.25 flat and post. And so then now you'll have all those files that you could run just as it is to be able to cut this out. So I'll send this video over, and then maybe once you guys take a look at it, if you have problems, I can send you this file. I can send you the ShopBot stuff too. Just let me know what you need. And again, sorry it kind of took long to kind of go through this, but I do think you were asking about modeling a little bit better. There's probably some issues in there, and I can definitely tell with the degree of the curve with all the ISO curves. They don't quite match up, so that's going to help make sure that everything's watertight if we start to kind of play with the degree of that curve. And again, there's a command called simplify curve. Like, I'll just show you real quick. If I take a curve, I can, you see all those points, I can type in simplify, and there it is, simplify curve. And then you can see how it reduced it. It made this a straight line, and then it didn't start putting control points in until I got to the curve. And so if you start generating your surfaces after those curves are simplified, it should help the congruency of those surfaces so they match up better. Okay, so give that a shot. But again, you can cut this as is. You don't need to do that. But if you do notice some weirdness, that's probably where it's coming from. Okay, I think that's it. So I hope you guys have a good night. And again, just reach out. Always happy to help if I can. So and good luck with everything with the MFA. Talk to you later. See ya.